Welcome to Lesson 5 of the USB Network Gate SDK tutorial. In the last video, we successfully set up the client application and got it to connect to the USB devices provided by the server. Now we'll go over some more advanced options for these connections. Where we left off last, our client program was able to view all the devices being shared by the server, and we could select any one of these devices and connect to it. But what if we wanted to connect to a device that's not listed? This could happen if the server and client are not running on the same network. To get started, we'll make a simple window called Add Device Window that lets us input the server IP or host name and port, as well as select whether or not it will be a callback connection. In the case of a callback connection, you don't specify a server address. Instead, you're just opening up that port and waiting for the server to begin sharing a device on it. However, a standard connection requires both the server host name and the port. The XAML design for the user interface here is all very straightforward and available in the sample project, so there's no real need to go over it. Instead, we'll focus on the underlying code. First, we'll add an additional model class that is specific to this window and basically just stores the server and port. You can connect directly to a device if you know the server's IP address and the specific port the device is being shared on. If it's been shared by the server and is waiting for a connection, then you can start this connection from the client. Otherwise, the device is just being saved to your local list so you can access it later, because you can't force start a connection if the server isn't allowing it. When the window is created from the Add Manually command, we create a new Add Device Window model and set it as the data context. Then, when the Add button is clicked, we'll get this model out of the data context and call its Add Device function. The net settings property within the model properly formats the connection string from the parameters the user entered, based on whether or not it's a callback connection. Then all the Add Device function actually needs to do is call client add remote dev manually, passing in this net settings parameter. With that all in place, I can start the client application, click Add Shared Device Manually, and enter the connection info. In this case, I'll set it to wait for a callback connection on port 10,000. Then, from the server, I can initiate a connection on that same port, and the client will accept it. These callback connections are a great feature because the client application can be set up to preemptively wait for a connection on a given port. In Lesson 3, we discussed some functions that let you share a device with a data-compressed or authenticated connection. Now we'll go over the corresponding functions to handle those features from the client side. And as it turns out, this is incredibly easy. The only thing our program needs to do is check whether or not a connection requires authentication, so that we can prompt the user to enter a password. So we'll go back to the connect function and call the SDK method client remote dev requires auth. If the auth parameter gets set to true, then we show a simple window to request a password. Once that's entered, or if no password is required, we can then proceed on to call client start remote dev. Like magic, the SDK then handles all the compression, authentication, and encryption behind the scenes, based on the server's settings. While you can't change these settings from the client side, there are a few SDK functions that provide information about the connection. Client traffic remote dev is encrypted tells you whether or not a connection is encrypted, and there's a similar function to see if the connection is compressed. It's worth noting again that while these functions all return Boolean values, those indicate whether or not the function exited successfully. The third argument to the function, the out parameter, actually holds the value you're checking. You can also connect to devices over the Remote Desktop Protocol, or RDP for short, instead of TCP/IP. And the SDK handles all of this behind the scenes, making it really easy to use. All we need to do is go back and add another class that implements the abstract group, which we'll name RDP Devices Group. Then we'll override the create context method and instead call client enum remote dev over RDP to create the context pointer. Going back to the list of groups in our model, add a new RDP devices group to the list in the constructor, and just like that, we've implemented RDP support in the project. Super easy, wasn't it? Now we will briefly demonstrate this feature and connect to a device using RDP. The computer running the server application will be considered the target, and it's the computer we will RDP to. Then, from a different computer, which acts as the client, I'll start a new remote desktop connection session and enter the IP address of the target computer and the appropriate credentials, which are blurred out here. When I hit OK, it starts the RDP session to the target computer. You can tell which part of the screen recording is showing the target computer because of this blue banner along the top of the screen. This means I'm physically using the client computer, but controlling the target computer with the RDP window. Then, on the target system, I'll start the server application, locate a device that's plugged into that computer, in this case a keyboard, and share it. You can see the status says waiting because nothing has connected to that device yet. Then I minimize the RDP session and start the client app on the primary computer. When I do that, the shared keyboard automatically shows up as an option to connect to in the client app. Clicking Connect actually opens the connection and seamlessly shares its data from the target computer to the client. Going back inside the RDP session, you can see the server application now shows the keyboard's status as connected, and it shows the IP address of the client that's connected to it. Minimizing the RDP session one more time and returning to the client, I'll make a new text document. You can't really see this because it's just a screen recording, but the keyboard that's typing right now is physically plugged into the target system, and its keystrokes are being captured and transmitted over remote desktop by the SDK. Because the connection is over RDP, we didn't have to specify an IP address or port in either the client or the server application. Instead, that's all handled seamlessly in the background by the USB Network Gate remote desktop features. Pretty cool, right? Now that we've gone over how to set up and configure both the client and server programs, you've got all the information you need to build an application with USB Network Gate. In the final lesson, we'll talk about how to activate and redistribute the SDK so that you'll have all the tools you need to deploy your finished project.